Hello everyone. I'm Anirud, and today I'll be talking about some of the work that we did to speed up Nextjs builds for like our Nextjs application with an unconventional tool like OpenTelemetry traces. For a bit of context on who I am, I'm Anirud. I'm a founding front-end engineer at Oodle.ai. We're building an observability platform for all of your metrics, logs, traces. And I worked previously at companies like Coinbase, Rubrik, and PayPal. Like about me is I like sleeping and sometimes I write code. So uh, yeah. So we were facing. Hello. Yeah. Uh, while doing product development for like Oodle, which is the platform that we're building, one of the things that started happening is our Next.js builds were taking too long. Um, Sometimes our Next.js builds were taking like more than an hour. And in that particular screenshot, if I zoom in a bit, oh, I can't, I can't zoom. You can see here, sorry, yeah, like some of the builds were taking even up to 6 hours and just basically timing out the CI. So how many of you have used Next.js to build your React projects or so? Yeah, quite a few. And how many of you have faced sort of like build time escalations as you were building the product so far? Okay, that's some like fewer of you, but yeah. So this is a problem that we were facing, and this is partly because we've been like building features with extremely high velocity thanks to AI. Um, but um, yeah, one of like yeah. So our build times were spiking. Our feature velocity was slowing down, so we needed to fix it quickly. Um, and so that was the objective that we set out to solve. So step one is sort of measure the problem. We had build times, they were spiking, and we had sort of rough visibility into that because we could see it on our GitHub Action CI, but beyond that, we didn't really know why they were spiking, or we didn't have any more detailed visibility into that. So step one was just to set up some baseline instrumentation. We already had this set up previously thanks to Thought, which is a library that allows us to emit OpenTelemetry traces for GitHub Action like steps. So as you can see in the screenshot, it basically gives a breakdown of all of the different steps involved in our GitHub Action CI. And you can see at the bottom, there is this big build and deploy services bar that's taking up pretty much all of the time. And that was sort of the sign that it's the build that's actually failing and not other stuff happening in the CI. So beyond this, we didn't have any more visibility, so we needed to add that. So that was the next step. Since our builds were essentially Docker images that we had set up, the next step was to set up Docker build kit, which is sort of like the runtime that Docker uses to actually build the images. Uh, that also, interestingly enough, emits OpenTelemetry traces. So if you sort of add like the driver opt variable to your Docker build kit, your Docker CLI command, that will also start to emit OpenTelemetry traces, and you can stitch those traces into your GitHub Action trace as well. So the caveat there is, by default, if you enable Docker build kit and it emits OpenTelemetry traces, it will emit a new trace by default. It won't add it to the existing trace. So the way to wire that up is just to set up a trace parent variable that will sort of link your GitHub Actions trace to your Docker build kit trace. So you get a full trace which has both your GitHub Actions as well as the breakdown into which specific Docker step took contributed how long to it. So once you have that set up, it will look something like this, where you have each, again, I can't zoom in. Uh, no, there's no way to zoom in, sorry. Yeah, there's no way to zoom in, but if you can sort of see, You can see each individual Docker build step, like the copy command, the run command, etc. All of those you can see in your trace as the individual steps. And again, we can see that in this particular case, it was the pnpm run build on like Oodle frontend, which is our Nextjs frontend app. That's basically contributing to most of the build time that you see. So you can see like out of the whole waterfall, the highlighted blue bar is taking up the most time. So that's basically our Nextjs build. So now we need more visibility than just that, right? We need to actually go in and improve our Nextjs build times. So the way to do that is again through more instrumentation. And interestingly, there is a way to get that instrumentation. So Nextjs emits this file called .next.trace. So that file has extremely detailed visibility into like the webpack build steps, how long each particular step takes, all of the breakdown like that. So this is a trace file that has like sort of thousands of spans or so, and it will give you like for each particular um, file, each CSS compilation step, JS compilation, transpilation step, all of that. You get the full visibility of sort of the Next.js build in that trace file. But that trace file is in its own custom format. It doesn't like normally speak OpenTelemetry, like it's not in an OTLP consumable format. So what we did is we built a post build script that parses that .next.trace file into an OTLP format and then ingested that trace and stitched it into the same sort of this same like Docker build kit plus GitHub Actions trace. So at the end, we had one trace that had like thousands of spans. I can't show that screenshot here because it's not like it's way too long. But once we had that trace, it had thousands of spans with detailed visibility into the GitHub Action CI steps, the Docker build steps, the Next.js Webpack compilation build steps. All of that fed into one trace. Just looking through it, we found that out of like an average 12-minute build time, more than 75 to 80% of it, like 9 minutes or so, was just spent in Webpack compilation. And thanks to the .next trace file that I talked about earlier, we got detailed visibility into which parts of it were taking the most time. But it wasn't very human readable, so I took the lazy engineer's route and just fed it to an AI. And the AI gave like a few interesting sort of insights. One was that like there was a build profiler environment command. We sort of removed that. It suggested some package import optimizations on around for around 24 dependencies that we were using. So it suggested a way to optimize that. It suggested that we enable Webpack build worker, which is a Webpack config to sort of enable a build worker that will sort of offload some of the build compilation steps to help improve the build times. There were some extra Docker files that we were like adding into our Docker images, like the storybook test, the unit tests. It suggested cleaning that up. And kind of interestingly, there was one particular component out of the thousands of components that we had that Webpack surface that, like, sorry, the trace surface that there was a disproportionately high amount of time being spent on that component. When I looked into it, it turns out that it was using like an older render pattern sort of pattern to render that component. So just did a quick refactor to convert that into a regular JSX component. And after all of this was done, the fixes hardly took maybe 30 minutes to an hour or so of my time. And yeah, once the fixes were done, our build times went down from 12 minutes to 9 minutes. So that's a 25% increase. But more importantly, our CI, the GitHub Action CI, stopped timing out, which was the critical problem that we had set out to solve, and we achieved it with like relatively less effort, and thanks to AI doing a lot of the heavy lifting for us. So the key takeaway for me, at least, was the hard part about solving this problem wasn't the fixes. The fixes were trivial thanks to AI. The hard part was what came before, which is actually setting up the telemetry, setting up the instrumentation, um, getting that detailed visibility to exactly what is happening at each step of the build process, and making it available in like a full single trace, so that I can actually feed that into the AI to sort of get my problem solved. And this particular problem is sort of um, like fairly common, which is Nextjs sort of build time increase. But there are other use cases where you could sort of apply the same principles of um, like setting up instrumentation, getting detailed visibility into all of the steps involved, finding out the rate limiting step, getting more instrumentation into that step, etc., etc. Um, that process is what was the takeaway for me. And thanks to libraries and ecosystems that OpenTelemetry has sort of built over the years, this sort of instrumentation is available for a wide variety of use cases that like any one of us can sort of start building with. Lastly, just a quick shout out, quick plug to like our platform Moodle.ai. So we are building an observability platform, and a lot of the things that I talked about, I was able to do because of the fact that I was using a telemetry like an observability platform that made it very very cheap to instrument all of my sort of build data, instrument all of my traces at scale very very cheaply. You could use any hotel compatible provider for all of the steps that I followed, but since we are building an observability platform, I just happen to use mine. And yeah, you can sign up for free. There's a free trial link there. And yeah, if you want a link to the slides, or if you want to DM me on LinkedIn, these are the QR codes. You can scan them. And yeah, that's it.